It is a question asked in JEE Main January 2025, 22nd morning. So it is a question related to the electrochemistry. A solution of aluminum chloride is electrolyzed for 30 minutes using a current of 2 amperes. The amount of the aluminum deposited at the cathode is dash. So in this question, the time t is equal to 30 minutes. So 30 minutes can be written as 30 into 60 seconds. And the current I is equal to 2 amperes. So here the aluminium deposited, here it is. We must know the equivalent weight of aluminium. Equivalent weight of aluminium is equal to atomic weight 27 by, and factor for the aluminium is 3 because Al3 plus has been changed to Al. That will be equal to 9. So here, according to Faraday's first law, weight of the aluminium deposited is equal to equivalent weight into I into T by 96,500. That will be equal to equivalent weight 9 and amperes is 2. The time in seconds is 30 into 60 by 96,500. So 0 cancel here, 0 cancel here. If you are calculating this value, you can get 0.336 grams. That is there on option 3, which is the correct answer for this question. So it is a question from chemical kinetics. Which of the following statement is not true about the radioactivity? Amount of the radioactive substance remained after 3 half-lives is 1/8 of the original amount. So radioactive disintegration reactions are said to be a first order reactions. So for the first order reaction, we have the formula. The amount of the reactant left after n half-lives is A by 2 power n, where n it is nothing but the number of half-lives, A by 2 cube. That will be equal to A by 8. So 1/8 of the original amount is left after 3 half-lives. It is correct statement only. The second one, decay constant does not depend upon the temperature. Decay constant, it is nothing but the rate constant. Rate constant always depends upon the temperature. In most of the cases, the temperature increases, the rate constant, nothing but the decay constant increases. So decay constant does not depend upon the temperature, it is a wrong statement. Next, decay constant increases with the increase in temperature. So decay constant increases with the increase in temperature, they are asking. So the correction is that decay constant does not depend upon the temperature. It is correct only because the decay constant it is independent on temperature. The third one, decay constant increases with increase in temperature. Decay constant does not depend upon the temperature. So it is wrong. So option 3 is the correct answer for this question. So the question given here, it is how many different stereoisomers are possible for the given molecule. So the given molecule is CH3 single bond CH, which is connected to OH, and which is connected to CH double bond CH, which is connected to CH3. So this double bond can exhibit the geometrical isomerism. So it is one stereocenter, and here it is the chiral center. It is the second chiral center. So the number of geometrical isomers the number of stereoisomers possible for the given compound is 2 square. That will be equal to 4, which is there on the option 4. It is the correct answer for this question. It is a question related to the thermodynamics. A liquid when kept inside the thermally insulated closed vessel. Thermally insulated closed vessel indicates which is an adiabatic system. For adiabatic system, Q is equal to 0. That means there is no exchange of heat in between system and surroundings. And mechanically stirred from the outside, which of the following correct option for the thermodynamic parameters? From first law of thermodynamics, you can tell that U is equal to Q plus W. When Q value is taken as 0, then U is equal to W. So when you are seeing the mechanically from the outside, there is a work done inside that particular process, then W is greater than 0. Whenever the W is greater than 0, U is also greater than 0. U greater than 0, W greater than 0, because U is equal to W and Q is equal to 0. So the correct option for this question is delta U greater than 0. That means change in internal energy is greater than 0. Q is equal to 0 and W is W greater than 0. Option 1 is correct answer for this question. So this is a question from haloalkanes and haloarenes. CH3OCH2Cl. Here it is. Chloromethyl methyl ether will undergo SN1 reaction, though it is a primary alkyl halide. The given one is a primary alkyl halide, but if I am going to take CH3, single bond oxygen, single bond CH2, Cl undergoes heterolytic cleavage with elimination of Cl minus, then you can get CH3, single bond oxygen, single bond CH2 plus. It is a carbocation and stabilized by plus M effect of oxygen. So it is the most stable carbocation, that's which can undergo SN1 mechanism, even though it is a primary alkyl halide. The statement 2 is neopentyl chloride. It is will not undergo SN2 reaction very easily, though it is a primary alkyl halides. In general, primary alkyl halides can undergo SN2 mechanism, but it is a primary alkyl halide that does not undergo SN2 reaction, because this particular CH3 single bond C, single bond CH3, single bond CH3, CH2Cl, neopentyl chloride, on dissociation you can get CH3, single bond C, single bond CH3, single bond CH3, single bond CH2 plus, neopentyl carbocation. It is a primary carbocation, but shifting this particular methyl group to this one, methyl shift takes place, then you can get CH3 single bond C, single bond CH3, CH2, CH3. You can get the tertiary carbocation. Then this undergoes SN1 reaction. So this particular carbon is having high steric hindrance, even though it is a primary alkyl halide. That's why SN2 reaction does not take place, only SN1 mechanism takes place. So CH3OCH2Cl will undergo SN1 reaction, even though it is a primary halide, it is correct. Neopentyl halide will not undergo SN2 reaction, even though it is a primary halide, it is also correct. Both statement 1 and statement 2 are correct. Option 4 is the correct answer for this question. So given below the two statements, statement 1, 1 mole of propane react with the excess of sodium, liberate a half mole of H2. So let us consider the propane, CH3, single bond C, triple bond CH. This is the propane. This propane, which is on reacting with the excess of sodium, then this hydrogen is replaced by sodium, then you can get CH3 single bond C, triple bond C with a negative charge and Na plus with the liberation of half H2. Half H2 means half mole of H2 is liberated. So this hydrogen is get eliminated as of H2. So the statement 1 is correct. Now if you go for the statement 2, 4 grams of the propane react with the NaNH2 to liberate the NH3 gas, which occupies 224 ml at STP. So for example, if I am going to take CH3 C triple bond CH, which is on treatment with NaNH2, which is called as sodamide. So sodamide abstract this particular proton, then you can get CH3 single bond C triple bond minus and Na plus, and there is an elimination of NH3 gas. NH3 gas. That means 1 mole of propane can produce 1 mole of NH3 gas here. So for example, if I am going to take the propane as 1 mole, then its gram molecular weight is 3 into 12, 36 and 4 grams of hydrogen, total 40. 40 grams can produce 1 mole of ammonia at STP, 22.4 liters. Then 4 grams can produce 2.24 liters. That means 2.24 into 10 cube. That will be equal to 2240 ml. 2240 ml of ammonia is liberated. But here only 224 ml of STP is given. So statement 2 is wrong. Statement 1 is correct. So option 2 is not option 2. Option 1 is correct answer for this question. So this is a question from chemical equilibrium. A vessel at 1000 kelvins contains CO2 with a pressure of 0.5 atm. Some CO2 is converted into CO on addition of graphite. If the total pressure at equilibrium is 0.8 atm, then find the value of Kp you are asking. So initially you are going to take the carbon. So this carbon which is on reacting with CO2 it is already initially containing. Then C on reacting with CO2 it has been changed to 2CO, carbon monoxide is formed. Carbon is a solid and CO2 is a gas, CO is a gas. At initial conditions, CO is a solid, no pressure is there for the C, and CO2 it is having 0.5 atm. Initially no CO is present, 0. At equilibrium, pressure of C solid is 0 because it is a solid. CO2 0.5 minus x and the pressure of CO is 2x. So now P total is equal to pressure of CO2 plus pressure of CO. So at equilibrium total pressure is 0.8 and the pressure of CO2 is 0.5 minus x and the pressure of CO is 2x. 0.8 is equal to 0.5 plus x, then x is equal to 0.3 atm. So at equilibrium pressure of CO2 is 0.5 minus 0.3, that will be equal to 0.2. Pressure of CO is 2 into 0.3, that will be equal to 0.6. Now I have to find the value of Kp. Kp is equal to partial pressure of CO square by partial pressure of CO2. No need to take the carbon solid because the partial pressure is not there for the carbon solid. Pressure of CO is 0.6 into 0.6 because the square is there. Pressure of CO2 is 0.2. 0.2 here it will be cancelled 3 times. 3 into 0.6, that will be equal to 1.8 atm. 1.8 atm is there in option 2, which is the correct answer for this question. The correct IUPAC name for this given compound is, so the compound given is CH3, single bond CH, which is connected with COOH and which is get connected with CH2, single bond CH2, get connected with CH, which is connected to COOCH3, that is connected with CH3. That is the compound given. So if you are giving the numbering, here are two functional groups are there. One it is carboxylic acid, second one it is ester. So according to the IUPAC preference order of the functional groups, we must give the least possible number to the carboxylic acids. Then it is 1, 2, 3, 4, 5 and here it will be 6. So its IUPAC name can be written as, so the 5 is having methyl group and 2 is also having the methyl group, then and the 6 is having the ester as a substituent, then 6-methoxy carbonyl, 6-methoxy carbonyl, 2,5 dimethyl. The longest possible chain is containing 6 carbons, hex, and the suffix name for the carboxylic acid is oic acid. So option 4 is the correct answer for this question. So the compounds which give positive Fehling test are asking. So here it is nothing but only the aldehydes. Which aldehydes? Aliphatic aldehydes. Aliphatic aldehydes can produce a red color with the Fehling's reagent. Aliphatic aldehydes, it is an aromatic aldehyde, benzaldehyde, which cannot respond to the Fehling's test. Ketone never responds to the Fehling test. It is an acetophenone. And here it is CH2OH, C double bond O, CHOH thrice, CH2OH. It is nothing but fructose. Fructose can give a positive test to the Fehling test. So C is correct. Aldehyde can give a positive test. It is an aliphatic aldehyde, can give a positive test with Fehling's. And it is not a aromatic aldehyde. It is a benzyl group which is connected to CHO, which can give a positive test with the Fehling test. So C, D, E are going to give a positive test and red color by reacting with the Fehling test. So C, D, E is there an option 3, which is the correct answer for the given.